Hello student, the question says two stars each of one solar mass 2 into 10 power 30 kg are approaching each other for a head-on collision. When they are at a distance of 10 power 9 kilometer, their speeds are negligible. What is the speed with which they collide? The radius of this each star is 10 power 4 kilometer. Assume the stars to remain undistorted until they collide. So use the known value of G. So the value of G, we will take it as 6.67 into 10 power minus 11. Now, what is this question? We have two stars. Each one is mass M and mass M. They're attracted towards each other by their own gravitational pull. So that means one star is slowly attracted towards each other. So once that attraction happens, both would simultaneously come closer and closer, and eventually they will collide. So at some point, like exactly at one point, they will start to collide. Their center of mass remains the same. Why? Because center of mass is not affected by the internal forces. So this is the situation. So these two stars are slowly combining and they are colliding. Now, originally, this is the distance bit. Let us take this as our reference distance. Why? Because it is given at 10 power 9 kilometer, their speeds are negligible. So at this distance, let us assume this has a zero speed and this has a zero speed. If I try to write what is the initial energy of the system, the initial energy of the system is minus GMM, potential energy, divided by R. R is the distance between them, R1. Plus, they don't have any kinetic energy. Kinetic energy due to the first one is zero. Kinetic energy due to the second one is also zero. Now, due to attraction, they are coming very close to each other. Let us assume somewhere to the center of mass they came and they started to collide with each other. So once they collide, what would be the final distance between them? The final distance between them would be nothing but the sum of their radiuses. Both are same stars. So this radius is R, capital R. This radius is also capital R. So we can write their final distance, the R final, is nothing but 2R. Now let us assume the velocity of this is V1 and the velocity of the other one is V2 in this way. What is the relation between V1 and V2? Here, there is no external force. There is no external force. Since there is no external force, we can assume that momentum is conserved. Momentum conserved means constant. Whatever is the initial momentum, we'll have the final momentum. What is the initial momentum of the system? M into 0 plus M into 0. The final momentum is M into V1 bar plus M into V2 bar. Based on the logic, if you rearrange the terms, we simply got V1 bar equals to minus V2 bar. What does it say? It simply implies that both would move in opposite directions, but their magnitude of velocity would be same. If I assume the velocity magnitude of V1 as V, for V2 also, the magnitude of velocity would be V only. Based on the same logic, let us try to write what is the final energy equation. So when we write the final energy equation for the same thing, so we get energy final equals to minus G mm, this is potential energy equation, by divided by the distance 2r. R is the radius of each one, plus half m into, here we only need magnitude of velocity, let me call it v square, plus half m into v square. And by conservation of energy, we can tell initial energy must be equal to final energy. There is no other external forces involved. So by conservation of energy, E initial equals to E final. And E initial is minus gm square divided by minus gm square divided by initial distance between them equals to minus g m square divided by the final distance, that is 2r, plus half mv square plus half mv square would simply become mv square. Now let us cancel the m on all the sides. We will get, I will take it to this side, gm by 2r minus gm by r initial equals to v square. Let me take it to the next page. So if I substitute it, we will get gm by 2 into the r value is given in the question as 10 power 4 kilometer. So in meter, it is 10 power 7 meter. So 10 power 7 minus gm by the initial distance between them. The initial distance between them is 10 power 12 meters by 10 power 12 equals to v square. If you notice it, 1 by 10 square is much greater than 10 power 7, almost 10 power 5 times greater. So we can take this value as approximately 0 in comparison. In comparison, I can almost approximate it to this value can be negligible because you can see the denominator of this is much larger. Like example, if you want to do 1 minus 1 by 10 power 5, you can approximate it as literally 1 only because this value will almost be close to 0. So in the same logic, we can write this approximately as gm by 2 into 10 power 7 equal to v square. So implies simply v equals to root of gm by 2 into 10 power 7. Now let me substitute those values. So root of g value is 6.67 into 10 power 11. The mass is given as 2 into 10 power 30 kg. So 2 into 10 power 30 divided by 2 into 10 power 7. If I cancel these two, 10 power minus 11. So 10 power minus 18. So we'll get minus 18 plus 30. So you will get 12. So V equals to root of 6.67 into 10 power 12. So square root of 6.67, if I do it in calculator, it is 2.582. So 2.58 into 10 power 6 meter per second. So 2.58 in NCERT, it is taken as 2.6. So approximately this can be given as 2.6 into 10 power 6 meter per second. Again, I will repeat, the key concept is, first, you should know that whenever there is no external force, their momentum is conserved. If the momentum is conserved and if the masses are equal, they will travel with same velocity towards each other. And once they collide, we will take the initial instant and final instant. We write energy equations. Whenever bodies are attracted due to internal energy, we solve the problems by taking the energy equations only. We take the energy equation in the first case, we take the energy equation in the second case, substitute them carefully, and we'll get our answer. Hope you understood how I have solved. Thank you.